Yo, welcome back. Hello everybody, welcome into the stream today. Not gonna front with y'all, I'm feeling like cheeks. I'm feeling like cheeks, Miss Kitty. I'm still in recovery from that In-N-Out burger. Something happened, man.
Hi Michael, got inspired by your work ethic and dedication to learn Python.
Hey dude, how's it going? Thanks so much for the message, thanks so much for hopping in here. When did you start watching? How long you been learning Python? Let me know more about you. Thanks so much for coming in, Akshith. Hopefully I pronounced that right. Let me know if I did. Akshith. Welcome in, dude. I appreciate those kind words. You're a really nice guy. It's over here. All right. Let's do a quick check on the old YouTube here.
Akshif says, "Ya learning since 2 months. Thanks for the reply."
Hello everybody, my name is Mike. Shout out to Rohit here for his comments on my latest video, Spectre Sim demo. Go check it out if you haven't yet. Shout out to Rohit. Big love to you, my guy. All right. I'm not gonna lie with you guys. Today might be a little bit shorter than normal. I'm just not feeling that great. I'm pretty smoked from. Dude, I had some In-N-Out burger last night for dinner. Dude, I'm wrecked. I don't know what is going on. Like, my gut is just completely out of whack. Like, I'm just toast. Why are you learning Python, Akshith? What's your motivations? That's awesome, dude. Have you been reading Python Crash Course or taken any CS50 courses or anything? $93 solved. Wow. Okay. Alright, I'm just doing a random problem here. We'll see. We'll give it a go. 1921. Eliminate maximum number of monsters. You're playing a game. You're playing a video game where you're defending a city from a group of number of monsters. You're given a zero-indexed array.
Lovell says, "Bro."
Hey, Level, how's it going? Hey, bro. You are given a zero-indexed integer
Akshif
array.
says, "Learning for landing a job in data analyst."
Nice, my guy. Alright, you are given a zero-indexed integer array, distance, and of size n, monsters, right? Where distance index I is the initial distance in kilometers of the ith monster from the city. The monsters walk towards the city at a constant speed. The speed of each monster is given to you in an integer array of speed of size n, where speed index I is the speed of the ith monster in kilometers per minute. You have a weapon that, once fully charged, can eliminate a single monster. However, the weapon takes 1 minute to
Lovell says,
charge.
"Are you sticking to Python or learning other languages?"
Just probably Python for right now, and obviously just some of the front-end languages we learned, but I don't really need to branch out for right now. This one looks kind of hard for a warm-up. I don't want to use my skip, though. You have a weapon that, once fully charged, you can eliminate a single monster. However, the weapon takes 1 minute to charge. The weapon is fully charged at the very start. You lose when any monster reaches your city. If a monster reaches the city at the exact moment the weapon is fully charged, it counts as a loss, and the game ends before you can use your weapon. Return the maximum number of monsters you can eliminate before you lose, or N if you can eliminate all monsters before they reach the city. What? What is this problem? Okay, we're getting creative, trying to get creative with the problems here. Okay, so let me write this out here. So you're playing a video game where you're defending a city from a group of N number of monsters, right? So you have N number of monsters. So we're given two arrays: distance, which is the initial distance of the monsters from the city, and then their speed, right? And so the indexes line up with one another, guessing that speed and distance have the same length, correlating to the same number of monsters, and yes, distance of size n, speed of size n. And so we want to, so it takes 1 minute to charge. The weapon is fully charged at the very start. You lose okay. So if you eliminate one monster, you have to decrease by a minute all the other monsters in order to get a value. This is weird. Okay. So, dang, I was not hoping for a hard one today, boys. Okay. Right, we have distance, which is an array of numbers, which is just their distance away, how many minutes they are away, and then the speed at which they move. Okay, so depending upon the speed, you have to reduce the distance by proportional to speed and eliminate that way. Okay, so let me think about this. So in the example we have distance of 1, 3, and 4 with the speeds of 1, 1, and 1, right? So on every iteration, all three of these monsters are going to move just one place, just reducing their decrementing their value by their speed, right? So we need to iterate through this distance array. Now I'm wondering, what if we had like an example of where speed wasn't 1, like here, where like we have 3, 2, 4 with speeds of 5, 3, and 2, right? So, okay. Your base case then, I think we would want to use like a recursive algorithm to kind of do all of our exhaustions, and our base case, no, not a base case, maybe not. A case would be, so in this example here, obviously the one that's 3 minutes away with a distance of 5, you would eliminate, you lose. You can only eliminate one monster, yeah. So like, you have to say like, okay, so then it's, you have to reduce down by.
Tim says good evening, Big Mike.
Hey, Mr. Tim. So like one of our conditions is if speed index of I is greater than or equal to distance index of I, we need to eliminate distance index I.
Hi guys.
If distance index I. Okay, so let's just think about this. So let's set up like let's.
Which problem? Shuao says, back to Leet cook.
Hey, how's it going? We're just we just did a random one here, which is this guy, 1921. It's kind of elaborate, but it sounds kind of fun. I was going to skip it, but it actually sounds kind of fun. I want to kind of give it a try here for at least like maybe like half hour or so. I'm probably going to be a shorter one today, boys. I had some In-N-Out burger last night, and it's still wrecking my gut.
Are you feeling better, Mike?
No, dude, I'm still wrecked from that In-N-Out burger. So let's pull up the whiteboard. Let's talk through this together, you guys.
Hello, Mike and everyone.
Hey, guy, how's it going, my guy? Hey, Ray. Let's talk through this one. Right, so we're obviously decrementing our distance, right? So we obviously say for I in the range of length
Hi, Mr. Butler too.
of distance, right? Right, that's what we'll say to get loop over distance. Or maybe I should rather use like a while loop to, or like a helper function, right? To just, but I'm not like recursively making two separate decisions to decide from. I'm trying to just go linearly through the list, evaluate one monster at a time. So maybe I should say I equals to 0, right? And say while distance index I, right, while the value is less than
Josh says this looks nice.
Thanks, Josh. So while distance index I, so we want to evaluate the current monster, while the current monster's
This problem,
this distance index I, this current monster is less than. Now, do we want to be less than or equal to the speed at index I? So if it's less than, if we want to break out
the silver dude says yo.
Well, let's not try to figure out the code here. Let's just go through the logic, actually. Okay, right? So this monster is equal.
Silver dude says normalize distance by the speed to give you a uniform metric.
Right? Monster equals distance index I. Right, so we're evaluating every monster. Right? Now, if I come across a monster, right, and I evaluate its speed. Speed of monster equals to speed at index I. Right? So we're evaluating the speed across distance. So now if we say if we take the difference between these two values of the monster's distance minus the speed, if that value, so I mean, we could go through, so there's a couple of things I'm trying to think about. So if the value of the speed is greater than the current distance, we have to eliminate, right? You have to get rid of it because on its next move, it's gonna burn you, right? Now, so if the speed is ever, like, if speed of monster is ever greater than or equal to monster, right, we need to elim the monster. Okay, right? We need to eliminate, hey King Hat, about a year ago. So we need to eliminate the monster if the speed of the monster is greater than or equal to, right? Because it's going to drop us to 0, meaning it's attacked us, and it's game over from then. Now, right, so if it becomes greater than the monster, we need to eliminate the monster that's currently on. So in this example, let's just walk through this first example here. We have 1, 3, and 4. Right, we're starting on, we have 0. Right, I is here. I is going to be in our first pass here at 0. Right? So here we evaluate and we have speeds up here. So we evaluate, okay, this speed is equal, so equal, need to elim, right? So if it's equal, we need to elim. So let's, on I of 0, we would eliminate, sorry, not this value, we would eliminate this value. Okay, I moves to here. I is here at 1. We obviously, so if we make a move though, so we need to keep track of recharge time, right? So moves made, right, would equal 1 here, and so we need to reduce or like would equal true, right? So then if we would come to, oh, it's interesting because we have to, I don't want to go through the array if I make a move and then go through to the end and decrease by all the values. I wonder if I can like stack my moves together, basically, right? I wonder if I can stack my moves, how many moves I can totally make per minute, right? And then evaluate how many monsters I can make, I can kill at like what rate, maybe like something like that, because I don't want to have to make another O of n, make it like really slow, and when I do an elimination, parse through the array from then forward and reduce by the speed of all the monsters from there forward, or even backwards, right? So I'm curious, like if we have 1, 3, and 4, right? We know that we have a total of the difference between these two values is 2, right? And the distance between these two values is 1. And the distance between these two values is 3. With 5, 6. We can make a total of each increments by a speed of 3. Interesting. This is kind of 1 minute charge time I'm thinking about, right? So 1, 3, and 4. Now I'm not really sure on what type of algorithm we really need, like if it's like a 2-pointer or whatnot. I haven't really thought about that yet. But 1, 3, 4, right? In the beginning of the distance of the monster is the first monster. In the beginning, the distance first monster is 1, 3, 4. You eliminate the first monster after a minute. 2, 3. Alright, you would have to go through and eliminate. So I'm trying to think of like an approach that I wouldn't have to use like excessive looping to do basically the recharge timer of my weapon. Because I'd have to go through and decrement by speed, the distance by speed, if I make a move for all other values in the array, all other monsters, even ones I've already seen before. So I'm wondering, what if you sort the array, and so you have the most highest priority monsters out front? Well, I guess that wouldn't, no, it really matters based on speed, right? And if you sort the array, you would lose your speed relation. Okay, so in total, we know we have a maximum of 4 minutes that we have to kill monsters, right? And we can only kill monsters once every minute. Well, I guess no, actually it would be based on the speed, right? So it would be, if the ones are up here, right? The maximum amount of time you have to kill a monster, the slowest monster is going to be this guy, and the fastest is going to be this guy, right? So obviously you need to deal with this one first. So by eliminating this guy, I would have to go through and reduce the monster value by here for all the other values of this monster's array here. Okay, so let's just think here. Let's say, okay, we have monsters number 1, monster 3, and 4 value with a speed of 1, 1, 1 out front. So then if we take, so if let's just, the one, I'm going to get rid of the ones because I think it's kind of hard to deal with the ones first. I want to try the example of this one here. 3, 2, 4 for distances, and speeds of 5, 3, and 2. Right? So let's take the, can we get a factor basically, like of speed per minute, right? 5 speeds per minute. So it'd be every minute is 1.67. Okay, so then let's think. So if monster 1 moves, right? If monster 1 or index 0 moves 5 speed and gets 3 distance, right? It moves like 3 inches per every 5 minutes, or 3/5. 3 just over 5 speed. Distance is the amount of minutes away. Oh, distance is in minutes, right? Oh, hold on. Distance is in kilometers. Okay, I think that would help. I forgot that these have units to them. Kilometers. And then speed is in kilometers per minute. Okay. So then we can get the amount of time basically just per minute by taking the kilometers, 3 kilometers, and multiplying that by 1/5 to give you the amount of minutes it will take. No, kilometers per minute was 5 kilometers per minute and 3 kilometers away. Which means it'll take 0.6 minutes. So it'll take 0.6 minutes for that. So you just need to eliminate the monsters basically by in increasing order by the amount of time it would take for them to get there per minute. Or something like that. I think we might be onto something here. So, right, in this example, we have speed in kilometers per minute is equal to 5, 3, and 2. We have distance, which is equal to kilometers, is equal to 3, 2, and 4. Right? So kilometers by your factor for each array. So 3 times 1/5, right? To get your minute on top gives you 0.6 minutes for this guy. Two times 1/3 or 2/3. 6, 7. About. And this guy just 4 times a half. 2. So 2 moves. So in one, he'll be here quicker than this guy. And then this guy will take 2 whole minutes to get here. So by eliminating this guy, we're stuck with this one. Now the thing is how can we use these numbers to how can we use these numbers to determine which ones to eliminate? Obviously we need to eliminate the lowest minute per minute travel first. I'll take 2 minutes to get here. I'll take 0.6 and I'll take 0.6. So then, like, what if we get an example? Okay, now obviously in this example we have to eliminate one, leaving this guy will be left and we're stuck. We can only make one move, right? We have to get rid of this guy or this guy, and by doing so we're stuck with the other one hitting the town. So we're stuck. Now in the example of this one, right, it's just proportional. Or sorry, it's just whatever. They'll be there in 1 minute, 3 minutes, and 4 minutes. So you obviously have to eliminate that guy. You obviously can eliminate that guy, and then you can obviously eliminate that guy because you have enough time. So the thing is you have to make sure, I guess, that all these values have a difference of 1, right? If they don't have a difference of 1, then you don't have enough time or something like that, because you'd have to recharge between the minutes given. So like in this example, all of these have at least a minute apart for their total, minutes, math down, whatever. So it would be okay. But what if we had like the 0.6 over here and the 0.6 over here, and the 2 in the middle? Well, then you would get that, and then you would get that, and then it would say true. Well, that's not true. Well, I don't want, and then because I don't want to have to do O of n squared and evaluate every single time against every single one of them. Right? Because that would give you 0.6 we have to eliminate, but then if it was in like a different order, then we couldn't just evaluate a single value at a time. Or could we like XOR these numbers with one another and see if we have a more than a minute left over? Because that would... I'll give you the... Yeah, I think what we could do is we could XOR, right? Could we XOR these numbers, like starting on the first one, and then floor down the value, floor down the result, right? By 1. So then, and then I would just give us one move, potentially. Maybe it's a different property. I'm thinking maybe it's a different... I'm never good at the XOR. There's some symbol we can use to basically cancel out. That's like a bit one though, right? So it's not what I was talking about. No, so it's not what I'm talking about. Back to the drawing board. So then we take this. So the sum would give you So what can we do with these times then, basically, to... The thing is we can't just go one by one. Well, if I take one away, I have to reduce by all the other ones. Right, so if I eliminate the smallest time, then I move forward, I would reduce it by the total amount of time taken. So 0.6, so 1 minute was taken. Is it greater than this number? Yes, we can't do it. So we just evaluate this array, this new data set here, value by value. Say if it is less than 1. Well, would you want to do it if it's less than 1? Because you just want to do the smallest one first. So maybe we sort this, right? So let's sort this array so we get the smaller ones up front, and then we make moves, and then we can only make as many moves up until you get to a point where your time taken is no longer less than the value itself. So in this one, we would make a move, we'd have increment time taken by 1, because we have 1 minute charge. Time taken is 1, which is greater than this, we would break and return just 1 move. If we sort the times. Let's try this. Right, we're gonna say minutes is equal to an array where we're going to let's just, I'll do this comprehension later. Let's just get some code out on the board here. So I'm gonna say, right, we just need to create the new minutes array. So if I want to do this, let's do, so we just do speed index I divided by distance index I, right? For I in range of length of distance. That would give us the amount of minutes. Then can we just call minutes dot sort? And then can we say moves? I'll say time is equal to 0, or we have an initial time of, no, we have no recharge, we're initially fully charged, right? So we'll say for a minute in minutes, if time is greater than, no, time is less than, go with my example here. Right, so time would be 0, which is less than the minute, which means we can make a move. So if time ever becomes greater than or equal to, if time is greater than or equal to minute, we're gonna break. Else we're going to if time, well, that means it's got to be less than, right? So just by default, so else we'll just say time plus equal by 1, and then, I mean, we don't even really need to modify the monsters list. We just return a single output of time. So let me think about this. So we're calculating out the amount of time that it would take per monster, basically. So monster 1 here would take 0.6 minutes, monster 2 would take 0.67 minutes, and monster 3 would take 2 minutes. By nature, this is already sorted, but we do call a sort here to get the least or the most pressing monster out front. And then we would eliminate him, increase a count to 1 from 0, and now that would eliminate. And then we would move to here, 1 is greater than here, we can't make this move yet. We can't make this move because we don't have enough time, basically. I don't know, it's interesting, I want to try it. Interesting. So even on my example here that I tried, we still failed. That should be 2. We would eliminate and we would move on. Time becomes 1. If I take Okay, so even the one that I tried this on, I didn't get the right output for. So this guy here, case 3. Why? We came in 0, we did this. Okay, we can make that move. We killed him. Oh, but the thing is you have 0.4 minutes left to recharge. Okay, so you start off at 1. You decrease by the amount of time it takes. So this would be 1 minute to recharge. You decrease by 0.6. That means you have 0.4 minutes left to recharge. You don't have enough time before you hit your next one. No, but it takes a whole minute to recharge, so it doesn't take a difference to recharge. Like, it doesn't, based on the time, right? So if you hit, it kills your entire, right? So right, you're at 0 for your how much you have to charge. You eliminate, your charge goes up to 1, right? Okay, so then if this is greater, okay, let's get a charge capacity. Let's keep a track of a charge equals to 0, right? And we'll say kills equals to 0. So charge actually equals to 1. We're fully charged, right? So we would, right, for minute in minutes, right, if we're coming across the 0.6, which is the first monster that's coming to us, we would eliminate him, causing our charge to go to 0. So we're going to say if charge greater, right? We'll say charged, and we'll put this as a true, right? So if charged, right, we're going to increase the kill, right? If it's not charged, right, and then we're going to continue, right? If it's not charged, sorry, and then we're going to set charged to equal 0, right? Charged is false, okay? Right, charge becomes false. Now in the next pass, charge is false. It's not charged, so it's not charged, so we need to check if the minute is less than or equal to 1, then we're going to break. Else we have enough time to charge up equal to true. Because it would be false here. We wouldn't need to actually set it to true because we would just immediately kill and set it to false. So kill plus equals 1 here. Right? So if you have charge on your weapon, you can make a kill and you can go ahead and set charge to false, meaning that it's out of juice, and you continue to move on to the next monster. Now you evaluate, okay, is this monster, will it take him less than a minute to get here while I'm uncharged? Okay, will it? You increase your kill. So if the time it takes is less than 1, right, you don't have enough time, you would have to break right then and there. Right, if it is greater than 1, you can make a kill and move on. So right, you don't even need to say if charged then. You can just increase the kill on right when you get there. No. Because this if charged basically is like the first go. Because you would technically, if you would say charge is equal to true here, you would make a kill and then reset charge to false here. And then you would reevaluate on the next minute if the minute is less than 1. Right, but you wouldn't really need to do this because you're just setting it back to false. Maybe. Dang it. Well, these are inverted. Maybe I have typo. I feel like you would have to kill the ones. Right, so you have 0.6, 0.67, and 2 minutes. You would have, if you do this, I mean, you could use 2 pointers through this and check between adjacent monsters which one to kill first. And if you make a kill and the one to the right of it is less than or equal to 1, then you just, okay, so we could say this: for I in range length of minutes, right? Could we, or minutes less than 1, we say j is equal to I plus 1, and then we say let's go kills. So right off the jump you would make a kill, right? And then if minutes index of j is less than or equal to 1, we are going to break and we're going to return kills here. If it's not less than or equal to 1, we're just going to continue and move I forward and kill every time we get to I and evaluate the monster to the right, the next one up. Potentially. Dang it. So this did 1, 3, 4. There's made a kill, move forward, made a kill. No, this won't work either. That's so I take this number and I go 0, 3, 2. It wouldn't work either. Some would be 7, 8, 7, 8. Some would be could you average? You went average minutes, no? I don't think so. You want to average and floor by length. That would give you 8 divided by 3. 3 floored. That would give you 1. In that example, that would give you 5, 6, 7. Give you 1 as well. I think that would pass all 3 test cases, but I don't think that would work. Well, I'm wrong, isn't it? Like, it gives you an in, or it gives you a flow. But that one at least. Not this one, though. 5, 6, 7. What? Seven, 8 divided by 3. Oh no, I'm done. I'm not thinking the right thing. Huh. Well, obviously you need to eliminate that monster, and you don't have enough time to kill the next monster. Right? So can we not just go make this a 2-pointer? This doesn't make any sense because right, if you find 0.6, 0.67 in 2 minutes, you would eliminate one, and you don't have enough time to eliminate the next one. And you do have enough time to eliminate that one, though. What even happened? Speed 5 divided by 3. Oh no, I think I'm doing this wrong. Oh, I'm stupid. Come on. Ah, I got this wrong. Right? So this should be distance index I times 1 over speed index I. Right? And then we sort and we say for I in range length of minutes, J is equal to I plus 1. Kills plus equals by 1. And then we're going to say if minutes index j less than or equal to 1, 3. Continue. Else you kill both and move forward. I 2 places. Well, you need to be able to kill the last monster on a successful full loop through. So you have to say kills plus equal 1, return kills, right? If it equaled, you wouldn't break, you would return kills here. Yes! No! Come on! Why wouldn't this one work? Okay, in this one, we have distance of 4 times 1 over 2. We have 2 times 1 over 1. And we have 8 times 1 over 4. This would evaluate to 2, 2, and 2. They would all come at the same time. Okay, so if they're equal to, if the values, so if distance, or sorry, if minutes I equals to minutes j, we're going to return kills as well. Right? Oh, and then if they're equal, if they're the same number, then we'll return kills. Else we'll kill the left value. We'll evaluate the right value. Oh, I didn't mean to submit there. Oops. Why is it doing that? So if they're adjacent values, you can just kill one of them. Okay, so we'll make a kill, then you make a kill, right, and then you move on. So if they're equal to or, you would return kills. So if minutes index I is equal to minutes index j, meaning you have two values that are the same amount of time to get to one another, which is here, right? You're going to kill off the left one, and you're stuck with the right one, and boom. So that'll now pass that case, but they're still stuck on that this case here. So this one is how can you kill 2 here? That'll get there in 2 moves. That'll also get there in 2 moves, and that'll also get there in 2 moves. Just distance divided by speed. Alright, you do distance divided by speed, and now you would get 2, 2, 2. So why would I need to expect output of 2 here? 4 divided by 2 is 2, 2 divided by 1 is 2, 8 divided by 4 is 2. So why is expected kill count 2 when they're all the same? You can only kill one of them. See it, Tim? That doesn't make any sense. You can only kill one of them. Right? This has 4 kilometers, 2 kilometers per minute. That'll be there in 2 minutes. 2 minutes. 2 minutes. So all these will evaluate out to 2. Okay, we're gonna work on this. So let's go. Let's say I am working on Leet code 1921 and am getting stuck close to the end. I am going to show you my current attempt. Do not show me code or give anything away. I am not sure why I am failing this test case. Right, and then let's give it the test case I was doing here. I get a minute of 2 for all monsters, meaning you're comparing minutes index I. Just set the Viking condition to check what the monster reaches you. You're starting to find 0, comparing I equal, but considering minute I. Can you really only kill one? When do you get your first chance? What? See, so all monsters arrive at the same time. Ask yourself, if all arrive at time 2, can you really kill only one? What, I'm gonna get collateral? Collateral damage? When do you get your first chance to act? Oh. You can act right away. Or you can meet them. Okay, so if you make a kill, the next number, okay, so we'll say if minutes, okay, so you make a kill, so let's just go through the minutes then. Right, you make a kill on I, or you say you gotta reduce its value by 1 because you made a kill. You're gonna kill it or you're not? You're gonna kill it. So I kill it. I have to wait 1 minute. That monster is now here in 1 minute. So I kill it, thus taking a minute away from the other speed. I had to wait another minute. Okay, so then let's just say kills. So you have to, how many kills you made is how many minutes you had to wait to make kills. So let's say if so if minute is less than kills, if minute's less than kills, so we'll take the 222, which gets here in 1 minute. We're gonna say, okay, minutes is 0. Okay, we can make a kill here. We're gonna make a kill, increase this to 1. Move on. Okay, take this one, reduce by that value is 1, which is less than or equal, so we can only make, you can make a kill there. But if it gets there on 0, so if it's less than 1, return kills. Kills plus equal. So you go over each value, you'd have amount of kills is 0 out front, right? You have 2 minutes, 2 minutes, 2 minutes. They're all gonna get here in 2 minutes. Okay, so I'm gonna go out and kill the first one. Boom. I increase my kill to 1 for this guy, and now I reduce the next guy by the amount of kill I made, so 1. Okay, I can make another kill there. I'm great. I'm not less than 1 here, so I can make a kill. So if it, or, okay, we'll say, val is equal to minutes index of I less than kill, right? Except if I had made 3 kills, I had to charge 3 minutes. So I return kills. So then I'll say if val is equal to 0, we're going to return kills. Or val less than 1, we don't have time to charge, which is 0. Return kills, return. So it would be 0 less than kills. We minutes, so 0.67 or 0.6 less than 0. Less 0 would be 0.6, which is less than 1. We would return kills. So that would give us 0. We need to do the kill though. We can make 1 kill. So I guess we would need to kill right up front. So let's kill the first. As soon as we get to a value, we'll kill. We'll calculate a value here. No, because we don't want to. We get the value and then we kill. Okay, so let's just say right away we can make 1 kill, right? And then let's start at 1 up to the length of minutes because we don't need to go to there. And so then we'll start off at 1. And then if the value will return kills. So this will be 0.67 minus 1, which will be negative. So we'll return 1, only for 1 kill only made on the first guy. We can kill the first one right off the jump. We don't even need to look at him. Got those ones. Okay, so now we're filling these 2. So we're only getting 1 here. We should be getting 3. So that's saying here's 1, 3, 4 for distances. We kill off the first one, we recharge. We take the kill. That'll be here in 2 minutes. Val will be here in 2 minutes. Do we have enough time? 2. Val is not less than 1. So we're going to. So we need to increase a kill. Right. And then keep going. Come on, baby. So close. Okay, I got that. I need to reduce the start charge. You always kill one monster at 0. And for each minute I, you can kill one monster where the rest are approaching. So monster index I must arrive later than. Oh, we can let I be the count of kills then, right? We don't even need this. Okay, so I get what you're saying. So you're saying let I be the count of kills naturally. I have a count bar. Works perfectly because you kill one monster per minute. Starting at minute 0. Asking some questions here. So I think it has something to do with the float, right? Because on a floor. It's ceiling. So if you ceiling, 0. Save. For minutes. Thing is this, why would you? Why would you? Oh. Okay, so if we go. Should I use the import math, or should I write my own ceiling function and split off on the dot on the period and subtract 1 from the right variable and add that to the value? Well, you can't split probably on a float. You'd have to convert this to a stir and then split on the decimal. Yeah, sorry, it's 1921. Right, so we would need to ceiling this value here. That wouldn't change it. That would just give us the amount of time in whole minutes, basically, per monster. I'm trying to think if I should just use the math.ceiling here. Right, or if I should use the write my own rifle time. To go up and through. So if the minute, so you wouldn't need to calculate. Okay, yeah, just need a ceiling. So we can clean this up by saying this. You could say this 0 length of minutes. In the range of 10 minutes. We're going to, if minutes index I less than I, return else. Return I. So I basically starts at a 0 counter by nature. So I think that this would also work. No. No. Really? Minutes is an I. It's less than I, you return I. But also if it would be to equal I as well. Oh, I can make a kill. Yeah, I can make that kill, and I'll count that index and move on. And you gotta turn I plus 1, because I is 0 indexed. There you go. Something's going on with this Leet code. There we go. Come on, baby. Oh, man, we were right there. We just needed that ceiling portion. We were able to get the speed portion, the amount of minutes it takes per monster, and then the sort part. We got this we got this first part pretty like, and then we were getting the loop portion, and then we just need to do our check. Our logic was what we were getting tripped up on. All right. Nice. Go on, throw me an easy. We'll see if I'll do it or not. I might be done here. If it's easy, I'll do it. Okay, we'll see here. You're given an integer n. We need to group numbers from 1 to n according to the sum of its digits. For example, the numbers 14 and 5 belong to the same group, whereas 1 and 3 belong to different groups. Return the number of groups that have the largest size, the maximum number of elements. Okay. Okay, so let's just write a helper function then, I guess, called that'll take in an integer and convert it to a string, and we'll call it parse sum, right? Given some num, which is an integer, right? And what we'll do is then this will return to us an integer, which will be the sum, right? So what we'll say is string, num string, is equal to we'll say num string. Actually, we'll say this: if num is less than 10, then what we're gonna do is just return the num. I'm trying to see, maybe there might be an easier way to do this, but let's just get maybe my first thing that came to my mind out of the way. So if it's less than 10, that means it's a single digit. Let's just return it. Right. And so then what we're going to do is we're going to return just a list here, right? The groups. So there are 9 groups in total. They are arranged according to their digits in order to 13. There are 4 groups with the largest size of 2 length. Okay. Got you. Oh. So we'll also need like a map. So we'll say like a group map is going to be a dictionary, right? Where the key is going to be val. Right, it have to be strings, right? Stir, val, key will be an empty list for val in range of, there's no 0, so 1, 2, n. We are including n. Okay, so this will make a map where we'll have a string of the value. Can dict keys be ints? I don't think so. Can we? Oh, yeah, they can. Then we'll just keep it. All right, so val with a key of a list for val in range of 1 to n plus 1. So this will be 1, 2, include 13, so 1 to 14. So then we'll say if the number, we're going to group map dot get num. We'll say group map key of num, right, dot append num. Okay. Else, if it's greater than, what we're going to do is we're going to say string num is equal to stir on the number. We're going to say total equals to 0. For char, or so for I in string num, we're going to int total plus equals int of I, the character, in stir num, or integer in this case, I would convert it. And then what we'll do is return, or we don't need to return, we'll just group group map key of the num that we're currently evaluating, right, dot append to its value list the total. No, this is going to be total, right? 1 plus 3 would be total, would be 4, goes into total append the num. So what we can do is now can we potentially, well, we can go like this, right? return here. Let me return group map of num. And then here, let me return group map of total. And then what I'll do is we'll say I feel like this is getting a little bit more complex than it should be. Oh well, we'll keep going. So I would have to convert the n to a string to be able to iterate over it. It's digits. Oh no, we're evaluating n2. Oh, range of n. Okay. For value, or for num in range of we're wanting to loop over our group map. Right. Right. We're going to call current list is equal to parse sum on the number. And what we'll do is say maximum group length is equal to 0. I'll take length current list maximum group length is equal to length of current list, or we'll say length of current list is equal to m. We'll say maximum group length is equal to m if m is greater than maximum group length, else continue. Loose motion? Oh, from yesterday. Got me there, bud. Okay, so, right, we create a group mapping for all of the values within this range that we're given, right? Now, what I'm going to do is I'll extract this out. I'll put r is equal to this, and I'll say r here, and I'll also say r here, so we don't have to call that range twice. That'll save us a little bit of memory. So we have a group mapping which is every value in the range of 1 to n plus 1 with a value as that key value as a list. So what we're going to do is for every number in range of R, right? So, right, we're going to access every number in the range of R, which is a range object. We're going to call parse sum on that number, which if that number is less than 10, we're just going to append the number to the group that it belongs to, the group of the number, append the number. If it's greater than 10, meaning that we need to iterate over its individual values and sum them together, individual, not values, but we'll say magnitude values as a 1's magnitude for all values, all magnitudes. Just basically concatenate together. I mean, we could probably like do some sort of like split or join and stir sum to make it easy, but whatever. For I in string of number, right, we're going to convert the number to a string so we can iterate over it. Every integer in the string, we're going to convert it back to an integer and increase the total by that. And then right. So this would be like 1 and 5 and 15, 1 and 3 and 13. It'll take 1 plus 3. And then what we're going to do is return the list that we currently created by adding that value to the group map. So 1 and 3 of 13 will add to 4, right? We'll go to the group map for the group at 4 and append the 13. Yeah, I'm definitely feeling a little bit under the weather today from yesterday. Okay, so then what we have here is we're going to go call the parsed list. This returns the current list from the map. We take the length of it and we override maximum if it is there. And we're going to return the maximum group length. Right? Dang it. Alright, we're failing this one. Here we go. Right, so we parse the value. And just get rid of this. So total, we parse and sum, convert to a string. For every integer in the string, we're going to convert it back to an integer and increase the total by it, and then go in the group map by the total at the end of the loop and append the number to its list. We're going to then return, let's just return length of group map total, right? And then I'll do this. Let's just call parse sum. Right? No. Turn null here. Okay. Turn the max found. Still getting that 2 and the 1. Let me write this out. Okay, we're going to parse numbers, so we have like 1. So then we'll say if right? So we have 1. I'll parse every. Okay, we go through a registry. This first one gives us should be 2. Only getting 1. I'll put there 2. Oh, the number of groups with the largest size. Oh, okay. I'm outputting the wrong thing. So we want to return the groups, the number of groups with the largest size. Right, so let's just go ahead and right, if we have to get the number of groups. Oh, if it's okay, so this returns group length. This is maximum. And we'll say groups equals to 0. So if it's greater than, so if the maximum, if the group length is greater than the maximum, then we're going to set the maximum. Elif m is equal to the group length, and we're going to set groups plus equal by 1. LFM is equal to group length. Then we're going to if it's equal to the group length, then we're going to increase groups. Right, else it's less than, you're just going to continue. Right, so you would get the group length back from your parse sum. You would then, if your maximum is less than the group length, then you have a new maximum group value. You would set that as the maximum, and then set your groups. Groups would equal 1, right? And then if it's equal to the group length, you would just increase groups, meaning you found a match of length. Else that it's less than, you would just continue. And then we were going to return groups, number of groups here. Something like that. Let's give it a try. Oh. Okay, we are pretty slow here, and I think I know why. Well, yeah, it's pretty obvious. So we were obviously converting to string and converting back to int and looping and yada, 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 yada. So instead, what we can do is we can extract off every integer by just using, so if I call, I always suck with this operator, but if I call 13 modulo, or the number, right? If I call the number modulo by, what do I have to say, like, would it be 10? That would give me off the 3, right? You just modulo by 10 to get off every ones place value every single time, and then reset the number. Something along those lines. So if we have while let's keep our def parse sum function given a number int, and let's go like this. Let's say while num, so if we go, num is like 13 modulo 10, that would give us back 3. And then we would reduce as a remainder. Then we would reduce the num by 3, gives us 10, then go left and then restart. Okay, let's go here. While num is greater than 0, what we're going to do is we're going to take the num, we're going to modulo it by 10. That's going to give us a remainder back, right? We're going to add the remainder to the nums list, and then we're going to set num equal to num less the remainder. And then we're going to return sum we're going to group total equals to sum of nums, and then we're going to say, oh, lost my tunes. Where'd my tunes go? We're going to say num, so we're going to total the nums list that we found for each one of the values, and then we're going to go into the group map, right? And we're going to go into the total, and we're going to append the num. And we're going to return the length of group map total at this stage. And then that will call here, return group length, and then we'll do our evaluation here. Right? So we have a numbers list. We're going to get to the integer of numbers. So for example, 5, right? So 5 is greater than 0. We're going to go in. 5 modulo 10 is going to give us 5 back. We're going to append 5 to the numbers list. We're going to decrease 5 by 5 to get 0. Okay, and then so that breaks out of this loop. Now we take a total, which is 5. We go into 5 and append 5. Then we return a length of 1 back. Now for, let's say, 13 for number, okay? While number is greater than 0, 13 is greater than 0. We're going to get 13 modulo 10 gives us the 3 in remainder. We're going to go to the nums list and add 3 to it. And we're going to reduce number, which is currently 13, by 3. So number becomes 10, which is greater than 0. Now num modulo 10 gives us a remainder of 1. Which is the single value. Now I append the 1. No, that'd give me a remainder of 0 because it goes in evenly. Right? How do I get that number back? So I give you the remainder, 3, then 0. If I have 13 modulo 10, that gives me back 3. So if I say, like, if I just want to use modulo... If you floor by 10, that would give you 13 divided by 10 of 1.3. Floored would give you the one you're looking for. So you need to floor by your base, divide by your base after the remainder is gone. But would you subtract out the remainder? It doesn't really matter because you're flooring anyway, so the remainder is going to fall off during the floor operation. So you could subtract by remainder and then just divide, but the floor is going to take care of that, I think, for us. Oh, no way. No way! Let's go. Okay. Nice. Cool, I'll say, okay. Sweet. I solved 1399 in 2 different ways. Don't show me code, but can you verbally give me some feedback regarding my approaches? Here's number 1. And then this is number 2. All right, here's some feedback and reflection of your 2 approaches, both solid with different trade-offs. Common strengths across both. Correct logic. You correctly calculate the sum of the digits for each number, group them by that sum, track the group sizes to find the max, and count how many groups match that size. Functional structure. Using a helper function parse sum makes the core loop clean and readable. Tracking max, group size, and count done cleanly with m in groups. First approach, digits math via the modulo and floor. More algorithmic, manually extracts digits without typecasting, avoids string operations, which may be slightly faster for small inputs. Minor notes, you're appending, but the point num is 0, you've reduced it to 0 during extraction, so group total append is just adding 0, which might not reflect the num you're grouping. In the string one, the string parser, right, clean and Pythonic, often easier to read for everyday development, works well with performance, isn't bottlenecked. slightly more overhead due to string conversion, but nothing to worry about here. First, more data sciencey, which is fine depending on your context. You're initializing a group map, which creates keys for every value through n, even though the actual keys will only range from 1 to at most 9 times length. But you're avoiding importance, which is okay. So I bet you there probably is like a trick to, right, you can only have 10 to the 4 right, 9999999 times the length, right? 9 is your maximum digit you can have, so the largest number you can have is n times 9 n's basically. No, it goes up to n. Whatever. All right, let's catch up on chat here. Okay. I think I'm done for tonight, but I'll roll the dice. If it's easy, I'll try it. All right, let me read it. We are given an array integer of digits, where each element is a digit. You're given an array integer where each element is a digit. The array may contain duplicates. You need to find all unique integers that follow the given requirements. The integers consist of concatenation of 3 elements from digits in any arbitrary order. The integer does not have any leading zeros. The integer is even. For example, in digits, if it's 1, 2, 3, the integers 1, 3, 2, and 1, 2, 3 follow the requirements. Return a sorted array of the unique integers. Alright, lots of steps here. Array of integers where each element is a digit. The array may contain duplicates. All unique integers that follow given requirements. The integer consists of concatenation of 3 elements from the digits array in any order with no leading zero. Okay. So we basically just need to come up with an exhaustive search or not exhaustive search, I guess. My headphones are dying. Headphones be dying. We need to come up with a search. I wouldn't want to build numbers like one index that had like be O of n squared. It's not what I would want. You need to combine 3 elements together. If the given digits were 1, 2, 3, integers 1, 2, 3, 2, and 3, 1, 2 follow the requirements. But not 2, 1, 3, no, because it's odd. Okay. So we just need to build all possible digits. with duplicate can contain duplicates. You need to find all unique integers that follow the given requirement. So unique integers. Okay, yeah, in terms of themselves, not so we can use duplicate numbers though. Like we could use 2 8s. Yes, we could. Can you only use the same digit that you're on once though? Share us your daily routine. You're looking at it, dude. Hey, Denotario, how's it going? We're just doing randoms just to practice, get some more practice with just strings and random problems. Every once in a while, just to keep up with our Leet code practice. But I mainly build projects. I just do Leet code every once in a while, because we have 100 problems solved almost. We have like 95, I think, so far. So just keeping up with our practice, not letting it go out the window every once in a while. Okay, so my thinking is if we sort this array, what's an algorithm to like make all the possible combinations, right? I know that there's like recursive ones for, like trees and stuff. But how can we do it over an array where things aren't linked together via like object pointers rather? Like how can we take like the first two? Yeah, we can make this here, but we can also take this, this, and this. We can take this, that, and then that, right? We can do all these different combinations. We'll have to think about this one. But anyways, that's it for me, boys. It's 10 o'clock for me here. I stayed up way too late last night. I didn't get hardly any sleep last night. So I'll be back tomorrow at around 7 p.m. PST. My name is Michael. Thanks so much for joining me here. I stream myself learning how to code every single day. Today we did some Leet code. Got some more practice there. We finished about 2 problems today on Leet code, which was good. Tomorrow we'll jump back into our Stalker project and keep going with that. So thank you guys so much for being here and hanging out with me today. It was super fun solving these problems with you guys. It was really good. We did a lot of good thinking here. Thanks, Justin. All right, you guys, I'll see you tomorrow. Thanks so much for being here. We're going to continue on with our reading and keep going with that tomorrow as well. I just wasn't feeling too hot today, to be honest. Like, I had that In-N-Out burger yesterday, and I've been just wrecked ever since. I don't know what happened. I think I got a bad burger or something. I definitely got, like, some kind of, like, food. My stomach, and I just been destroyed, man. So, I'll see you guys tomorrow. Thanks so much for being here.